Okay, we have a short, I hope, video for you today on section 2.4, use postulates and diagrams. So we're going to have 6 or 7 postulates. They're kind of short, but it's a lot. So remember, a postulate is a statement that we just accept as fact. So postulate 5 says through any 2 points, there exists exactly one line. These are things that I think we might already know, but they're just really spelling it out for us now. There's 2 points. There is only one way to draw a straight line that touches both of them. So through any 2 points, there is exactly one line, or only one line. Pretend like I hit that point there. All right, so that's postulate 5. I always tell you, you don't have to memorize the postulates or the numbers, but for today's homework, it'll be faster for you if you have this little list with their numbers, and you can just write postulate 6 instead of writing out what it says. Postulate 6, a line contains at least 2 points. I don't really know how to draw a picture for this, but if I give you a line, you know it at least has 2 points, and it has an infinite number of points, actually. Postulate 7 says if 2 lines intersect, then their intersection is exactly 1 point. Some of the homework will be giving you a picture and you choosing which postulate it is. So let's say we've got this line and this line. They are intersecting. And what is their intersection? It's that point right there. And remember, our book won't usually draw that, but that point right there is their intersection. Postulate 8. Through any 3 non-collinear points, there exists exactly one plane. So if you will ask me about my grandfather's stool, I've got a little story I can tell you if you want to hear it. But for now, through any 3 non-collinear points, there's exactly one plane. Do you remember how we could not have collinear points to form a unique plane? And we talked about the hinges on the door and how the door could swing on the hinges and it would represent lots of different planes. So in order for us to determine exactly one plane, I could use 2 of those and some point not on that line. So that could be that exact position right there. Through any 3 non-collinear points, there's exactly one plane. Postulate 9. A plane contains at least 3 non-collinear points. So we're talking about this box, and we're going to talk about this top plane. And it has at least 3 non-collinear points. Got this point, and this point, and this point. It actually has 4, but 4 is at least 3. So let's back up to this one. A line contains at least 2 points. So it contains these 2 that allowed us to draw it, but there are others, but it has at least 2. All right, almost done with these. Postulate 10. If 2 points lie in a plane, then the line containing them lies in the plane. Okay, so we have these 2 points right here, which are on the front plane. If those 2 points are on the front plane, then the line that contains those 2 points is on the front plane. That's what that one says. And last but not least, postulate 11. If 2 planes intersect, then their intersection is a line. Okay, so if we have 2 planes that intersect, their intersection is a line. First thing I want to talk about is that 2 planes don't have to intersect. We can talk about the top and the bottom. They have no intersection at all. They're never going to cross. They're parallel. But if 2 planes do intersect, like maybe the top and the front, then they are always going to intersect in a line. 2 lines intersect in a point. 2 planes intersect in a line. Okay, so now let's look at examples and see what we would do with our homework. So example 1, state the postulate illustrated by the diagram. So if you have a picture and then there's a picture. Well, what do you notice about the 2 pictures? 2 lines are crossing. Oh, 2 lines are crossing with a little red point here. If you can see that, it's kind of faint. So which postulate is that? Well, that's the postulate 7. If 2 lines intersect, their intersection is exactly a point. So we just say postulate 7. All right, B part. We have a picture of 2 intersecting planes. And then we have this picture of 2 intersecting planes with a faint red line here. So what postulate is that? It's the one we just had, postulate 11. If 2 planes intersect, then their intersection is a line. All right. Let's see if we can look here. Almost done. Oh, why is it so zoomed in? There we go. Use the diagram to write examples of postulate 9 and 10. So postulate 9 says, I shouldn't have shown you the work. Pretend like you don't see this. Okay, postulate 9 says, a plane contains at least 3 non-collinear points. So we're supposed to use the diagram to write examples of postulate 9. So postulate 9, we could say plane P, and let's look and see if we can find 3 non-collinear points on plane P, which is that darker blue plane. Plane P has non-collinear points You want to use BA. Those are collinear, so I need one that's not on that line. What about C? BA and C. Postulate 10, looking back at our notes to read what it says. If 2 points lie in a plane, then the line containing them lies in the plane. Okay. So if 2 points are in a plane, the line that contains them is in the plane. Well, I only see 2 lines. I see line M, and it only has 1 point on it. But line N has 2 points on it. So we can say B and A are in plane P. Line BA is also in plane P. Just something like that. Just showing that we understand and know how to use these properties and postulates. We're getting ready to get to a section called proofs, where we're going to just use lots of logic to show that one thought leads to another. The next thing we're going to do is, I'm not going to spend time with this with you now. I'm going to ask you to look at this on your own on page 89. These are things we can assume and things we can't assume from a picture. That's really important to see. I'll just point a few out. You can assume that all the points that are shown are coplanar. So when you look at this plane, you can assume that every one of them is on that plane. But related to that, you can't assume that G, F, and E are collinear. Let's find those. They sure do look like they are. But if there is not a line drawn there, you cannot assume they're collinear. So just read through those. Those are really, really great things for you to get in your head, things you can do and things you can't do. Last thing we're going to talk about is this picture here. Whoa. So a line is a line perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So that's a pretty complicated definition. So this line can be called a line perpendicular to this plane if it intersects the plane in a point, which it does, and it's perpendicular to every line in the plane that intersects at that point. So right here, here's a line in the plane that intersects at that point also. And right here, they're trying to show, see that red box? They're trying to show it's perpendicular to it. And vice versa, here's a line that is on the plane, and it intersects that point also. Goodness. And our line has a right angle box right there to it. Okay. I can talk about that more on Monday. I think you're ready to attack your homework now.